Hi guys, so in this video I wanted to quickly talk about something I forgot to talk about for the nomenclature. And what this is going to be dealing with is going to be naming cyclic molecules and how to apply Scizor Trends descriptors to those molecules in regards to their substituents. So I'm just going to start off with some examples, and I want to draw the molecule chair conformation, and we're gonna be asked to name it. Okay, so that's what this looks like. All right, so this is a basic chair conformation, and on it we're going to have some groups. So over here we have this group, and she has a carbon, and this is from an old exam. All right, just doing some very real examples. And on this group, CH, these are parentheses, CH3, 3, C, oh no, that's not a 3 right there. Okay, all right, then we have a carbon, and the parentheses. Okay, so this is our molecule, all right? So I have this, the carbon, these are the parentheses for this. All right, so I need to name this molecule, and essentially, like I said, this chair conformation is just a cyclohexane. It just is drawn in the chair conformation format. Okay, so we need to be able to decode this into an actual molecule. So the parent chain is always the biggest chain, and here the biggest chain is going to be the 6 carbon long, the 6 carbon long cyclohexane. Okay, so cyclohexane is going to be the parent chain name. So the first molecule name is cyclohexane. Okay, so that's the parent chain, and we need to start naming the substituent. So the substituent over here, it's easier if we draw it out. So attached from parent chain, right? I have a carbon, and off of this carbon is 3 other carbons. All right. So like I said, when we name a substituent like this, we can name it 2 things. So this is a 4 carbon, 4 carbon substituent. So 1, 2, 3, 4. We can call this either T-butyl, or we can call it using the method that I prefer. There's a formal name to refer to these methods, but there's just 2 methods. So you can either call it, right, 1, 1, 1, right, dimethyl ethyl, right? That's what I would call it. So that's this group, and this group over here, so I have a carbon that has a hydrogen off of it, and attached to it is a CH3 group. Okay, so I have that CH3 group, and this is attached to another carbon, right? So this is this one right here, and then this is the CH3 group. This CH3 group is attached to this is the CH3 group right here, and this carbon attached to this carbon. A parentheses denotes that this is coming off the chain, right? In some way, it's not the main chain, right? So the main chain is this carbon, these 2 carbons. So this attached to this attached to this, and off of this one I have 3 CH3s. Okay, so this is what this substituent looks like. All right, and we don't have an easy way to name this using the nice fancy methods. So we have to name it the substituent on a substituent method. So I start numbering, finding the longest chain in the substituent. So this is 3 carbons. So, and then on this I have a methyl group right here, a methyl group right here, a methyl group right here. So the name for this is going to be, right? So 1, 2, 2, trimethyl right? Me eat peanut butter, so trimethylpropyl. Okay, so that's this one. Now to build the whole name. The whole name is going to be, so now to organize this, I have dimethyl, ethyl, and trimethylpropyl. So the di and the tri don't count as part of the alphabetical order. And so I need to look at ethyl versus propyl. So E before P. So I have 1,1 dimethyl ethyl, and then right. Okay, wait. One other thing. All right. I forgot to number the chain itself, so I need to have a number over here. So I'm gonna delete that. So how do I number this chain? Do I go 1, 2, or do I go right? Or do I go 1, 2? Either way, it's the same thing, right? I still have 1, 2, 1, 2. This is the case where I have to look at the alphabetical ordering of these substituents. So, like I said, this is ethyl, this is propyl, so I'm gonna go 1, 2. Okay. So this is gonna be the butyl or the whatever the ethyl group is gonna be 1, and this is gonna be 2. So on my name, right? And I'm still missing something, but we'll talk about it. Right, I have 1, and then in parentheses, right? Because this is gonna end up being in parentheses. So 1, 1 dimethyl ethyl. Okay. Then another dash, then 2, right? Because that's the position on the cyclohexane. And then 1, 2, 2 trimethylpropyl. Okay. And then I have to add the cyclo part because it's not a hexane, this is a cyclohexane. Okay. And I'm still missing something. Okay. At the beginning of the you have to be very careful when you're looking at cyclic materials, right? So especially cyclohexane and you know, whenever stereochemistry is just the dash and wedge, so that's stereochemistry. Whenever those things are there, you have to indicate whether indicate the stereochemistry in some way. The way that you guys know, the only thing that you guys know right now is Scizor Trends. So I have to give a descriptor for whether to how these molecules are related here. So are they cis? Are they trans? You know, what's going on? So as you can see, both of them here are in the equatorial position, okay? And I'm just gonna say right now, these are trans, all right? And I'll explain it. So these are trans, and to understand this, I'm going to convert this into the regular cyclohexane, okay? All right, so, okay. All right, so that's the regular cyclohexane, and then I need to add the groups. So we said this is 1, so this is 1, this is 2. Actually, let's just make this down here. So this is 1, this is 2. 1 is just the T-butyl group, okay, and 2 is this crazy group, so like this. All right, this is what I have. And I need to describe these as Scizor trends based off of knowing that they're equatorial, okay? So like I said before in the previous video, that equatorial, I can choose to whether make it dash or wedge, doesn't matter, just have to be consistent, and I have to understand how that's going to affect the next position. So if this is equatorial, and let's say I make this into the light wedge, right, dash, so I'll make this into a dash. That's how it would look. It just looks weird like that, okay? Or you could also just draw it like this, put the actual dashes to the first carbon. That means that this one's also equatorial, so that means this is going to be in the dark wedge. So to make them both the same thing, I have to make this a dark wedge, okay? So, you know, kind of something like that, whatever, colored in. Ooh. All right. So dark wedge. So like I said, when I say this is axial, when I say this is equatorial, that means that light wedge over here, which is just a hydrogen, is now axial, and that means this is equatorial. So now I have designed my molecule, what it looks like, and I have allowed them to both be the same equatorial. So now I see that the groups are on dash and this one is on wedge. So they're on opposite colors, opposite dash and wedge. So that means they're trans, right? And to translate this into chair conformation, so you don't have to do this every single time, whenever on your chair conformation that your groups are both, like when they're next to each other like this, and they're both the same type of, I guess, positioning. So if they're both equatorial, that means that they're trans, okay? Obviously, it changes as you go down, right? Because this is light, it'll be helpful if you draw it, what it looks like as the regular chair, as a regular cyclohexane. But if they're next to each other, which usually makes it like that, if they're right next to each other and they're both the same equatorial, then that means they're trans. Or if they're both axial, that means they're trans. If one is axial and one is equatorial, then it's cis. Okay? So not too bad. Now let's look at a different type of problem that she does for nomenclature. So she does something where she says, she gives you the name, she gives you a name and you have to draw the molecule. So cis 4,4, right? So cis 1-4,4, actually there's a parentheses right here. Okay, 4,4 dimethyl pentyl, and then 2 tert pentyl, right? Cycloheptane, all right? So that's our thing, right? Ignore the spaces. So this is my molecule that I have to design based off of the name that I've been given, right? So I need to figure this out. The first thing to do whenever you're drawing a molecule from its name is to look at the parent name, okay? So pentyl, okay, this is the substituent. So the parent name starts from right here, the cycloheptane. So what is cycloheptane? Heptane is 7 carbons. So I need to draw a 7 carbon ring, right, which is kind of annoying to draw. So that, okay, like that, there. 1, 2, 3, 4, 5, 6, 7. Okay, so that's what a cycloheptane looks like. Okay, and then now I need to add the substituents. So I'm just gonna call this as 1. This is 2, 3, 4, 5, 6. This is 7. Okay, so this is 1. That's 7. All right, so I have to take note of the cis part. On carbon 1, I have a 4,4 dimethyl pentyl. So pentyl, right? So that's 5, right? So I have 1, 2, 3, 4, right? 1, 2, 3, 4, 5. And I have 4,4 dimethyl. So on the fourth one, I have 2 methyl groups. So it looks like this. All right? And okay, on the fourth one, it looks like that. And then on number 2 of the ring, I have a tert pentyl. So tert pentyl. So like I said, tert is always at the end of your. So let's say this is the parent chain. Tert is always at the very end. Tert is always at the very beginning, right? So no matter how many carbons long this, I could say tert, nonal, whatever. All that means is the first carbon has these 2 CH3 groups on it. Okay. So I'm going to draw. So on 2, I need to draw this, and then it has this and this. So I've used up 3, so I need to add 2 more. So 1, draw it downwards, 2. So that's what I have. Okay, that's what I have right now. And now the final thing, I need to make sure it's cis. So like I said, cis is when both the dashes and wedges are the same. So either both light or both, dark. Okay, so it's up to you however you want to make this, but I'm going to make this dark, and I'm going to make this dark. All right, and that's pretty much it. So this is now cis. If I want to make it trans, I would just keep one of them light. Doesn't matter which, right? So that's pretty much it. And cyclo is just making it into a ring. So this is cyclobutyl, it's a square. This is cyclopentyl, cyclopentane, right? It's this cyclohexane. This is cycloheptane. All right, so not too bad. That's the end of this video. All right, see you guys.